The Rock Whisperer. Do you hear the earth talking to you? Unit 7 continued. This is section 7.8, Deposition. So deposition is part of the erosional deposition process. We break down the rock through weathering, and then we transport and put the rock down in another place. So those sediments are carried in different types of medium, and the word medium refers to what is doing the carrying, whether it's a glacier, whether it's the wind, water that's moving it. So when we deposit those particular sediments, it's also known as sedimentation. Sedimentation is part of forming sedimentary rocks, which we can kind of see in this diagram down here on the bottom when we talk about what's happening. So we see the sediments being carried in the stream. As they get buried, it gets deeper and deeper and deeper. And as it's getting deeper, the water is being squished and pushed out, and the sand is being pushed, or the sediments are being pushed closer together. We wind up with a sedimentary rock. As we know, eventually that gets weathered and eroded, forming new sediments. Then they get buried and compacted again, and we go through that same process. So what are the methods for depositing? Well, one, they can be dropped by flowing water. So when the water slows down, the sediments will eventually fall out. Think of a stream or a river running into a larger body of water like a lake. So when that lake has that river running into it, the water is slowing down from the river. And when that happens, the particles will start to settle out. Larger particles settle out of the transported medium. So with wind would be the same way. As the wind is slowing down, larger particles would fall out. Also, particles that are dissolved, or the minerals that are dissolved, can eventually precipitate out. Again, that can be a temperature change, or that can be something to do with a chemical change in the water. So how do different things affect deposition? This particular picture we have down here on the bottom shows us what's happening with the size of the particles. The bigger the particles are, the quicker they fall out. You're going to have water, as we talked with the water running into the river running into the lake. These are going to be the large gravel particles, sand, silt. We can see it's just a teeny dot here, and then clay. We can't even see on this particular scale. We wouldn't be able to see it. So these bigger particles will fall out quicker, probably mostly because of their mass, that they're more massive, so therefore they're going to fall quicker. Shape, which is the second diagram here, is going to show us that rounder particles settle out faster than particles that are more elliptical or more flat. So if we have something that's round, it will fall out relatively fast compared to something that's flat. Flat, you're going to have more water pushing up on that particle to keep it afloat. So clay is a particular type of particle that is a flatter type particle that the water will hold that up. Remind me to show you the paper example in class for that. You can also talk about density. The more dense a particle is, the quicker it falls out. And also the velocity of the stream. The faster the water is going, the more particles that can be held up. And that goes back to the diagram on page 6 in your reference table. And last are the types of deposition. We can have unsorted and random, or we can have sorted. The unsorted and random look like this particular picture here, and you can see there's a picture of a rock hammer in this showing you size. This would be something like a glacier, the end moraine or terminal moraine, or it could be something gravity. We have particles and stuff falling off the side of a mountain. So the second type is the horizontal or vertical sorting. So for horizontal, we're moving with the horizon. We can see that the mouth of the river is going to have larger particles, and that the further you get into that larger body of water, whether that is the lake or the ocean, you can have smaller particles. Those smaller particles can actually get out to be fine silt or clay, and even eventually some things could precipitate out. When we have vertical sorting, moving up and down, okay, we can see in this particular picture that we go from coarse and we get finer and finer until we get very fine on the top, and then the whole pattern starts over again. And the reason we call that seasonal is because sometimes this is what happens when there's flooding. You have a area where you have sediments being brought in, and in the springtime when the water is moving faster, we have runoff from the snow, we start to have the larger particles. And then as the season goes on and there's less and less water, the particles get smaller and smaller. Then the whole process starts over the following year. So we can kind of tell what's happening from year to year with that.
Don't forget to listen to the earth. You just may hear it speak.